We will discuss quadratic equations in two parts. In the first part, we will do very basic quadratic equations and ideas, very primitive factoring and quadratic formula tools. And in the second one, we will do more advanced types of quadratic equations. So let's start with the first part. A very fundamental type of quadratic equation is going to be a quadratic equation with leading coefficient equal to 1. And we can factorize it using Vieta's theorem. For example, to factorize this type of equation, you need to think about two numbers whose product is this negative, the free term, and the sum is this linear term. In our case, that is 10 and negative 8. When you multiply these two numbers, it's negative 80. If you add them, it's 2. So you can write the quadratic equation as x plus 10 and x minus 8. So that's going to be factorization of this quadratic equation. So if you open the parentheses, you should get x squared plus 2x minus 80. Then after that, you can solve each of the linear terms separately. So you can set x plus 10 equals 0. That gives you x1 is negative 10. So that's the first root. So x2 is going to be just 8. So the roots of this equation is negative 10 and 8. Sometimes if you have parameters, you can apply the same idea just with taking into consideration the parameters. For example, here, the product of two numbers should be minus 4ab. So I would go, so since looking at these two, you can go with 2a and minus 2b. When you multiply them, you get minus 4ab. If you add them together, you get 2a and minus 2b. Factorization here is going to be x plus 2a and x minus 2b equals 0. And if you solve the first linear term, it's going to be x1 is negative 2a, x2 is just 2b. So this is the most primitive form of quadratic equation, and this is the one that you are going to see the most. Sometimes it's not possible to solve it using the factorization. For example, you can think two numbers whose product is 3 and sum is negative 6. So the two numbers whose product is 3 it could be just 3 and 1. 3 plus 1 would not give you 6, it's maximum 4. In general, in these cases, it is some irrational numbers. So that's going to be a little bit tricky to figure that out. So that's why we are going to do completing squares. So in order to complete the squares, recall the formula for a minus b or a plus b squared. So you have a squared minus 2ab plus b squared. So you need to try to find the b of the expression. So you have x squared, so 2. So you need here 2ab. So just divide this number by 2 and try to make the remaining equal to the square of that number. For example, we have 6 is, for example, we can rewrite 6 as 2 times 3 and plus we need 3 square. So we can add, so to make 3 square is 9. So to make it 9, we can add 6 to the both sides. So that becomes 9 and 6 here. Now this part is just x minus 3 square is equal to 6. If you take the square root of both sides, that gives you x minus 3 is equal to square root of 6 plus minus. Since this is an equation and we are taking square roots, we need to make plus and minus. There are two options. And adding 3 to the both sides, we get x is equal to 3 plus minus root of 6. So this means x1 is going to be 3 plus root of 6 and x2 is going to be 3 minus root of 6. And finally, the quadratic formula. If the first two methods don't work, you can use the quadratic formula. For the quadratic formula, I suggest you to divide the quadratic formula into two parts. In the first part, you just evaluate the discriminant of the equation, which is b squared minus 4ac. For this one, it's also b squared minus 4ac. So here, in this equation, this is a, this is b, and c. So you have to know how to identify the coefficients, right? So let's do the discriminant of the first one. B squared is negative 8 squared minus 4 times a. is 4, c is 1. So negative 8 squared is 64 minus 16. That's going to be 48. So discriminant of the equation is 48. Now the roots are x1 and x2. It's minus b plus minus square root of discriminant. So we know what is discriminant, over 2a. So that's going to be minus b. So we have b minus b is negative 8. So minus 8 plus minus square root of 48. Since we know that discriminant is 48, 2 times a, 4. So if you simplify this 8 plus minus root of 48 over 8. So this is going to be roots of the given equation, 2 roots, plus and minus. Now let's do the second one. So the discriminant of the second equation is going to be negative 2 squared minus 4 times 3 times 5. Then that's 4 minus, if you multiply these all together, it's going to be 60. And this is negative 56. And during your calculus classes, you'll be working only with real numbers. So here discriminant is negative number. So that means this quadratic equation has no real roots. So you can stop solving the quadratic equation and say that this equation has no roots because the discriminant is negative number. So this is it for quadratic equations for now. The next video we are going to do more advanced types of problems.